In section 7.1, we learned how to interpret the area underneath a normal curve. Namely that the area under, well, normal curve, as in any continuous distribution, is actually the probability of finding an x value, a random x value in that region. And you can interpret that as a probability or a proportion. So the question becomes, how do we find that value? So in this particular example, it was 0.3085. Where does that come from? And the answer is, well, you're going to learn how to use your calculator to do it. So remember that the normal curve has this function right here as its value, which of course is a very, very complicated function. You can see the x in there somewhere, along with a whole bunch of constants, including e, mu, sigma, and pi. But we're not going to work with that function by hand. In order to do that by hand, you would actually need to take Calc 2. So we're going to make the calculator do it for us. So we're going to start off with finding the area under a normal curve, and then we have another direction that we're going to work with in another few pages. But let's start off with finding the area. So you always want to draw a normal curve and shade your area with appropriate labels, and then you're going to find your area under your normal curve using your calculator. So these are the instructions, but I'll show you how to do it here with these examples. So I have here mu is equal to 20, sigma is equal to 2, and I want the probability of 19 less than x, which is less than 23.5. So I need to start off by drawing a normal curve. 20 is in the middle, 19 on the left, and 23.5 on the right. And I want to shade in between because it's telling me that x is in between those two values. So let me draw that curve and I'll be right back. Poof, there it is. So we have a normal curve. 20 is in the middle right there, and I have 19 over here on the left, 23.5 over here on the right. Yes, you must draw this curve, put those two numbers down, put 20 in the middle. Now we want to find the area that we are finding here with the computer. You can see the computer thinks it's 0.6514, but the question is, how do you get that? There, and I just made it a little bit bold for you to be able to see better. All right, so we're going to use the calculator. Let me pull this up. I'm going to clear all this out over here. Now, the normal distribution is underneath the distribution menu. So you want to hit second, variables. You want number 2, normal CDF. We never, never, never want normal PDF. That's another function. Well, it's the same function, but it's a different value. We're not going to work with it. And then you can see here it wants to know the lower, the upper, the zero, and the mu, and the sigma. So when you look at what you've shaded, the lower edge of what you shaded is 19, and the upper edge of what you shaded is 23.5. So what you're going to do is put in 19, that's your lower, 23.5, that's your upper, your mean was 20, and your standard deviation was 2. And you're going to go down to paste and press enter, and then press enter. And you get 0.6514, just like it said you would. And that becomes your calculator entry. So for these problems, it'll say your calculator entry. See that part right there? So what that means is that you type, or you write, normal CDF, then you put in your left, which was 19, your right, which is 23.5, your mean, which was 20, and your standard deviation, which was 2. And then you say what the answer was, which is back. There you go, 0.6514. Technically, that's an approximation because, of course, there are more decimal places there. So I'll use the approximation sign. And you're done. That's it. That's all there is to it. Simple as that. All right, so let's do another one. Now this time the mean is 75, the standard deviation is 8, and I want to know the probability that x is greater than 90. And remember, greater than or equal to, it doesn't matter for continuous distribution. So you need to draw a normal curve. You want to have 75 in the middle. 90, of course, is on the right of that, and you want everything that's to the right of 90. So let me draw that picture. There we have it. So we have a normal curve drawn. 75 is the center. Then I have 90 over here on the right. 90 is a good long ways because your standard deviation is 8. So then put 90 kind of a little bit past, well, almost quite to 2 standard deviations away, but not quite. And then you want to have this area shaded, and then you want to label it. And of course, the question becomes, where did you come up with the 0.0304? So again, it's going to be normal CDF because I'm using a normal curve here. So normal CDF, and then the question becomes what to what? Normal CDF. Now you always want to go left-hand edge to right-hand edge. That's the way this works. So I want to look at the left-hand edge of what I shaded. Well, that's 90. But the right-hand edge of what I shaded, that's a little bit harder to come by because technically this curve goes on forever and ever and ever and ever to the right. But the calculator doesn't have a forever button. It doesn't know what that means. So I'm going to have to pick a really, really big number. And the biggest number your calculator can handle is scientific notation. It's 1e99. That's going to stand in place of infinity. So when you have a right tail shading, then you want 1e99 to stand in the place of that positive forever. So I'm going to say 1e99. I'll show you how to do that in your calculator in a second. The mean was 75, the standard deviation was 8. And that should be approximately 0.0304, but I'll prove it to you in just a second. All right, so let me go type this into the calculator. So I'm going to go second distribution menu, pick number 2, normal CDF. My lower was 90. My upper is 1E99. Now E is the double E that's above your comma button. See how it says block letter EE? That's standing for exponentiation. It's standing for scientific notation, times 10 to the. So you hit second comma. It's a lowercase block letter E. It's not quite as big as the full capital E. The full capital E is alpha, the sign button, S-I-N. You can see that's quite a big letter. That's not what we want. We want the lowercase block letter E that's above the comma button. All right, then the mean was 75 and the standard deviation was 8. And I paste, and I press enter, and look at that, 0.0304 when you round it. And since it's rounded, of course, that's why we use the approximation symbol. So it's approximately 0.0304. All right, done with that one. Now, let's do it again. This time the mean is 30, sigma is 4, and I want the probability that x is less than 25. So let me draw that picture. So there we have the normal curve. We have 30 in the center. I have 25 over here to the left. And then I have this area right here, which is 0.1056. So the question becomes, how do I find that area? So again, we're going to use the normal curve. So normal CDF. All right, normal CDF, what to what? You always want low value to high value, or left to right. So you want to look at what you shaded. Now the left-hand edge of what you shaded is forever to the left because this graph never stops going left, right? That x-axis is a horizontal asymptote, so it keeps going and going and going. So what I want to say is negative infinity, but the calculator doesn't handle negative infinity. It doesn't know what to do with that. So instead you have to use negative 1e99 to stand in the place of negative infinity, which I wrote right here in these instructions right here. So for left tail shaded, you're going to have to use negative 1e99 to stand for negative infinity. And remember that E is above your comma button. All right, then the right-hand edge of what you shaded was 25. The mean is 30. The standard deviation is 4. So we'll need to find what this is. All right, so it's going to be 1056, but how do I get that? So let me grab my calculator. Second distribution, normal CDF. This time I want a negative 1e99. Negative is down here at the bottom. It's that little negative in parentheses value, not the minus sign. That's a different thing. So negative 1e, second comma, 99. That's 1 followed by 99 zeros. Then I want to stop at 25, 30, and 4, if I'm not mistaken. Let me go back and double check those values. Yep, 34 and 25. All right, so paste, enter. And there you get 1056, just like the computer said it would be. All right, so let's do the last one now. Oh, okay, this is going to be a little bit tricky. It's less than 165 or greater than 200. So let me try to draw a picture of that. It might be a little bit complicated. One second. Now with this problem, we're talking about two different regions. X is less than 165. Now 165 is over here on the left, and I want less than that. So I want to shade over here to the left. or x is greater than 200. So 200 is over here on the right, and I'm shading to the right. Now, what you could do is you could find each one of those tails separately and add them up. That would work. But there's an easier way. The center area, that kind of white region in the middle, you could find the area of that pretty simply. And then remember, the area under the entire curve is 1. So what you really want to do is take 1 minus this area in the center. And that's 1 minus normal CDF. Now think about that central area. You want the left-hand bound of it and the right-hand bound of it. So the left-hand bound would be 165. The right-hand bound would be 200. The mean is 180 and the standard deviation is 12. So this is approximately 1 minus, and now we got to go find it. So let me go find what this is. So let me bring up a calculator. I'm going to clear this out. Second distribution, normal CDF number 2, and then we said 165, 200, what was it, 180? 180 and 12. Okay, so 180 and 12. Paste. And I find that that value is 0.8466. And then I take 1 minus that answer. Second answer gives me 0.1534. So this is, hold on, come back. There we go. 1 minus 0.8466. And that is approximately equal to 0.1534. So it's the complement rule, again, from chapter 5. We don't want the area in the center, but we find the area in the center. And we take it away from 1 to find the area in the 2 tails put together. Keep in mind here that you don't actually know what either one of the tails is, nor do you really care. You want to know what they combined together up to be. So the other way to do this is to find this probability on the left, this probability on the right, and add them because it's an OR probability. See the word OR in there? So you could find each portion separately and add them, or you could just find the central portion and take it away from 1, and you know what you were looking for in the 2 tails.